Hey guys, thanks for tuning in. Today we're going to unbox, set up, and do the first test prints on the new Ender 3 S1. Right out of the gate, what makes this different from something like an Ender 3 version 2? And the primary thing, though there's a few things, the primary thing would be the hot end. So this is a direct drive hot end. This hot end is identical to the one that we saw on the CR10 Smart Pro. And they borrow a lot of the same design cues and some of the same parts, like this ribbon cable from that printer, and some of the parts from the Ender 3 V2. This should be a very familiar screen to you guys. So that's the key differentiator. Obviously, it's got a little bit of a different look overall as well. And there's probably some electronic differences. First things first, test filament. In here, they say in the documentation that for rigid filaments that 0.8 millimeters of retraction is going to be enough. Being that it's direct drive, it is going to be significantly shorter than 4, 5, 7 millimeters even on a Bowden setup. I think 0.8 is probably optimistic, but we'll find out. And obviously that might be a little bit more if you have a particularly oozy material like say PETG or something. But that's what their literature says. We'll have to affix this, of course, to the X carriage. But first, let's take a look at the other parts that we have here. So we've got this little clip, and this is going to be the clip for the ribbon cable on the back of the gantry there. We have the spool holder, two-piece spool holder, like that, and the filament runout sensor. There's a bracket here. I think this is for the screen. Yep, the screen slots into there, and this bolts onto the machine. Of course, power cord. And then our bag containing all the assembly tools, screws, and the instruction manual. So I'm going to take a quick second and look through the instruction manual myself. All right, so in that bag of tools, of course, there's the assembly manual. There's the stabby pin for, for clearing a clogged nozzle. I call it that because I put one through my finger, and I mean through my finger. We have a limit switch with a little bracket. So this may be the Z limit switch. I don't know, we'll find out. Let's just dump the rest of this carefully here. So we have a full-size SD card and a USB SD card reader. It's an 8 gig card. Our bolts and hammer nuts and whatnot, a spare nozzle, and then a bag of the assembly tools, the scraper, which is a sharpened scraper, and a flush cutter here. So the first step in the manual tells you to install the hot end onto the X carriage. I'm not going to do that. I'm going to skip that step. I like to get my gantry installed first, and then I can more easily bolt everything on it up here instead of dealing with this thing laying down on the desk and whatnot and bolting into it. So for this, we need 4 bolts. It's going to bolt up through the bottom of the sides here. There's little milled cutouts that the uprights here, the 2040s or 4020s, 2040s, that they will slide into. So it's notched. There's no question as to whether it's properly aligned. It's going to slide right in there. And we need these 4 M5 by 45 millimeter bolts, and they have lock washers on them. They give you 5. So we need these 4 big guys. And like we've always done, I'm just going to slide this to the edge of the table here very carefully to give me easy access to bolt up from underneath. And then, as I mentioned, that will slide right into those milled slots like that. Perfect. Okay, so holding that there, just bolt in underneath, 4 bolts, and then we'll go on to the next step, or back to the first step if you're following the manual. All right, so this guy is going to attach to the X carriage here with 4 screws through the side. This kind of is actually a nice setup. This screw here will go on the back side of this bracket. Just kind of like wiggle it like this, and eventually it'll sit itself there. Now, obviously I wouldn't just like leave it like that, but it will stay in place. And then we've got 1, 2, 3, 4 screws in the side. These are these M3 by 6s here. There are 5 of them, so I think we have a spare or one for later. The manual was super tiny, so get your glasses out, though my glasses didn't really help me much. There we go. Once I've got one in, I don't have to worry about it falling off anymore. So, even with one in, I mean, it's secure. There's very little play in these holes, so you don't have to worry about like alignment issues or anything. So screw in all 4 screws, and then we'll go to the next step. So now on the back side of the X motor here is where this little clip for the cable is going to go. And this clip fits right over that bracket there like that. It's just press fit. And then the idea is that right where this little tag shows you, you're going to slide the cable into the clip like that. There we go. And I guess it's worth mentioning now that the dual Z here are joined with a belt at the top, so they're synchronous. So you saw the unit move down as I kind of pressed this into that clip. Both sides will move equally. We're not going to have it kind of go off kilter like a single Z would. And this really helps keep both sides completely in line in that regard. Likewise, you could, if you're raising or lowering it manually, you can just spin one side because it will just translate across the other side and spin the other side. All right, since we're back here, even though the instructions don't really show this yet, we'll connect to the X motor. It's labeled like all the Creality cables have always been with X. So that guy goes in here, and then there we go. The other cable here, little 2-pin guy, is going to be for the X limit switch, I would assume. And that is underneath here. Sorry. It's underneath the cover on the front here of the X motor. So it goes right under here. And that's for this switch there for the X limit. And while we're here, of course, I connected the spool holder wrong. The spool holder portion, the cylinder here, should go on the same side as the filament runout sensor. We'll connect it up here in just a sec. The next step is the screen. So on the front left-hand side of the unit here, we've got a ribbon cable coming out, and we've got a couple tapped holes inside. We're going to attach this plastic bracket. There are 3 screw holes here, and those line up, unsurprisingly, with 3 tapped holes there. So this will go like that to put the screen on a bit of an angle. And there's these 2 like little jut out linear pieces. They go in this cutout on the side just to make sure that everything's perfectly aligned there. So it kind of locks it in place. And then we have 3 of these longer M4 by 18 screws. Again, they give us 4, we just need 3. Oh. Okay, so screw through the plastic into the side of the rail, and then we'll come back. All right, so I got the angled bracket bolted into the side, and then this guy is just going to slide with these 2 posts in here. Once it's on there, we'll connect the cable. We could do it before, I guess. Doesn't really matter. There we go. Slide that in like that, slide it down. Perfect, not going anywhere. And there is a warning here about the voltage. Make sure your voltage is correct for your country. The voltage selector is on the back, and ours is set to 230 volts. So ours is not going to power up if I plug it in right now. So right here, covered with a little plastic sticker. It gives you warnings and tells you what to set it to. Pull that off, and just use like an Allen key or something and slide it until you see the voltage for your country. So 230 or 115. Considering they have 2 different warnings, I'm pretty sure they've had a few customers that have had that set incorrectly. In our case, it wouldn't turn on, but if you were in a region that had 230 voltage and it was set to 115, it would blow your board or power supply or both. The magic smoke would come out anyway. Okay. For the uprights here, start connecting some cables. So this is one of the Z motors. There's a little rubber cap cover for these ports, which is interesting. So it's labeled Z, it's labeled PWM 24 volt expansion interface, and then the filament detector. So connect this. The filament detector is taped to the upright here. Okay. So the cable for the filament sensor is taped to the upright. Connect that to the third port here. And I believe the expansion interface 24 volt PWM is just going to be empty, unpopulated for now. On the other side, the other Z motor, it's this cable here obviously. It's the only thing we can plug it into. And the Y motor is already pre-connected. So on the hot end, this connector here, if we open these, it's keyed, so it only goes in one way. It'll plug in like that. And it does look like this little bracket here is meant to have the cable actually like tucked into it. It wasn't clear in the manual, but it's pretty obvious that that fits perfectly there. And without bending any pins, there we go. And so as you press it down, those fingers should grab it. That's not going anywhere, good and secure. And then I think we should connect the spool holder. So this is going to go like this. So we've got the cable here for the filament runout sensor. I just hook the spool holder on the front little lip there, push it down, just friction fit in place, kind of center it somewhere around there. And then the wire for the filament runout sensor into here. I think that's good. Let me see. So the limit switch in the bag with the bracket and everything, that just says spare parts. So this may be like an X-axis limit switch for under here. It appears like the Z limit switch is provided by the BL Touch or Creality Touch, whatever they're calling their probe these days. So this is spare parts, not installed by default. We know that we've got a couple extra spare screws and whatnot. So I'll place those aside. More garbage. And so the last thing, before we warm it up and get printing, is tensioning the wheels. So at the factory, someone went a little hog wild on these wheels. They're extremely, extremely tight to the rail. So much so that what testing they did at the factory actually dug little grooves into this wheel. I wouldn't say dug them in, but it's worn into the sides of the wheel, which is just indicative that it's too tight, right? And then as far as the bed, rolling it back and forth, you could see it right there. It's stuck in an indent on the wheels, and there it is again, right there. So the wheels are just simply too tight. When they're too tight, if they sit there for a while, it can create like a little bit of a flat spot, which is kind of like what we're seeing here. So let's adjust our eccentric nuts and loosen these wheels just a little bit. Obviously, you want them tight enough that, as I've said before, as you're rolling any individual wheel, there should be enough grip there that the entire assembly rolls down, and it is. You don't want it so loose that things have any kind of play in them. So I'm just going to loosen this guy this way. Yeah. There we go, that's better. Okay, so a little bit more. You just don't want any one wheel to be slipping or anything as you're spinning it by hand. So. There we go. And it's not Herculean, it's not super tight. Good, and it's smooth, rolling smoothly. Okay. We will want to tension the X belt here. So it's super, super loose and floppy. Just turning the screw will provide some tension to that belt. All of the belts on here are Gates power grip belts, which is what we like to see on all of our machines these days. There we go. Now, when you are moving things by hand like this, move them slowly. You can induce current backwards through the stepper drivers and blow them. I've seen videos in the past of people lighting up their screens by moving it back and forth real quick. Don't do that. And so on here, we're just going to loosen them, and probably only one side is adjustable. Yeah, so only the screen side is adjustable, and there are two, there's two wheels on either side. So find a position where you can reach the wheels, and you'll have to kind of play with which direction makes them tighter or looser. There we go. Tighten that one back up, and then the back one here. Sorry, it's impossible to show you these. They're really buried underneath there. Okay, so I got the eccentric nuts here loosened just a little bit. You know, I did the normal test to make sure when I roll them, they're still making good contact. You can feel this tiny detent on the wheels. It may go away over time, but it's not actually like jolting the bed into a position, so that should be fine. One point of note is that I don't know why they put the eccentric nuts on this side. This is the side of the printer with all the obstructions. You've got the wires at the back here, you've got the screen here, and it makes it very difficult with that tiny little wrench to reach those. Obviously, it would have been a little easier if I had done that adjustment before I attached the screen, and it does come off pretty easy, so you can do that to make your life a little bit easier. But make sure that you do that for all the wheels. At this point, I'm ready to plug it in, level my bed. You still, yes, want to generally level your bed, and do some test prints. So I'm gonna take it away. I'm gonna do all of that, do test prints. When we come back, I'll show you that bed leveling process. We'll review the screen. It's gonna be likely very similar to the Ender 3 V2, and I'll give you some feedback on my first impressions of this machine. Okay, so I've already printed something, obviously, but I'm gonna run through the process of leveling, and then we'll talk about some of the print experiences. And this is part of that. So we need to level our bed. I know that we have auto bed leveling. You know, we've got the probe. Where's the probe? There it is. So we've got the probe, BL Touch style, but you still wanna make sure that your bed is at least reasonably level. You know, that's to get us that last, say, 10% there or so, and to account for any non-uniformity in the flatness of the surface, right? So we'll obviously bring our bed up to temperature, so we'll go over to prepare, and you know, you're gonna see these menus, they look just like the Ender 3 V2 menus, very, very similar. So we'll go to Preheat Pla, and I can hear the fan kick in and it's preheating. I've already got PLA in there from before. So that brings me to my first point. Why is the fan on? I know, you know, if you're PID tuning your hot end, you should PID tune your hot end in a realistic scenario that you're gonna be printing in. So if I was PID tuning to print PLA, I would PID tune with the cooling fan on. It turns on the blower fan, the part cooling fan, while it's preheating PLA. I don't understand why. All that's gonna do, if anything, is increase the amount of time that it takes to preheat, and there's no purpose for it to be on. Now, you can turn that off on here. While that's preheating, we can actually do that. If we go back, if you go to Control, there's some presets for, sorry, Control and then Temperature. And then there's presets for preheating PLA settings and preheating ABS settings. So if you go to Preheat PLA, you can see that PLA fan speed, I've turned it to 0, and I've saved those settings. So now when I hit Preheat PLA, it's not gonna turn the fan on. Likewise, if for some reason you want the hot end to be at a different temperature when you choose Preheat PLA, you can change that there, and the bed temperature, which I'm not sure if it was stock that way, but I set it to 65. So go back, go back, go back. And at the bottom, of course, we can see the set temperature on the hot end and the current temperature, so we're already at 195. The bed also heats up really fast. You know, whole 24-volt system is expected. The bed is at 53, heating up to 65 right now. So while that's heating up, I'll talk about the bed. So this is a similar kind of build tack type of material that we've seen on Ender 3s and all the series basically since then. It's a little less aggressively textured than some of the others, but even with proper leveling, proper nozzle spacing, I found that the PLA that I used like welded to the sheet. Now I know typically that's because your nozzle is too close. And initially, yes, it was too close during my 3 perimeters. The nozzle was too close, which means that out of the factory, the Z offset, there was too much of a negative Z offset. So that means that it was bringing the nozzle closer to the bed. You can live adjust that on here. And I did that, and I saved those settings to just bring it up just a little bit. So as it's first doing those perimeters, you can adjust your Z offset to bring the nozzle closer or further away, which is one of the benefits of doing something like 3 rings of perimeters to give you an opportunity to do that. I'm also doing a purge line down the side here just to prime the nozzle, of course, make sure that it's full of filament and filament's extruding before we retract and then move over to the center. In my prints, my slices, I used Super Slicer. Doesn't matter, you can use Cura, whatever. I was using the default profile for the Ender 3 V2, and I just adjusted, since the build volume and everything's the same, I just adjusted the retraction to be 2 millimeters. No, sorry, 1 millimeter. Their documentation, as I mentioned last time, said 0.8 millimeters for PLA. I thought that's pretty aggressive. 1 millimeter is fine, and it's definitely not too much that you're going to retract too far and cause a jam or something. You could probably go all the way up to more than 2 millimeters and be perfectly fine. But that's one of the benefits of direct drive, is you should be able to significantly limit the amount of retraction needed, and you're limiting the amount of stringing and oozing that's happening. So that's the first thing. Now we're up to temperature. You're used to seeing the level bed menu, where it'll bring it to the front corner inset a little bit and kind of move around the 4 corners and optionally the middle portion. We don't have that here. So your level option here will immediately start doing a bed leveling setup. Okay? So what I did is I went to prepare, move, prepare auto home. So let's let it home X, Y, and Z. So it's homing the Z in the center, Z safe homing. That's just to make sure that the probe is over the bed when it homes. And also, probing in the center kind of limits how much it's off. If our bed is askew, the center is kind of a bit of a pivot point, more or less. After you're done homing the Z and doing the corners, you'd want to home the Z again, and then that's where we'll check our Z offset. Okay, so we're good. So now you have to manually move the probe, or sorry, the nozzle, to each of those corners that you want to level. So you'll just use the move X, and you can see it's in real time. You don't choose the number of millimeters and then hit go kind of thing. You have to just scroll like this. There we go. And then move the Y, other direction. There we go. Okay, so I'm still inset a little bit. Oh, I've moved too far. Move back. Okay. And then the Z right now, we're at apparently 12.3 millimeters. And as I'm lowering it down, 4, 3, 2, 1, 0. Okay, so leave it up a little bit, put your piece of paper in, bring it down to 0. You should feel that proper amount of drag. If not, tighten the wheel and move around. Do that at least twice. When you're done that, you would then go back and auto home again. And then in the center here, we bring the Z down to 0, do our paper drag. It should be a proper amount of way. And if it's not, you could then adjust the probe offset to just bring the nozzle up a little bit or down a little bit. And like I said, when you're doing your print, you can also adjust the Z in real time. Okay. That is the next thing. I was hoping it would do it. So sometimes it pauses. It'll probe, and it does the 2 probes. It does one and then the second. It'll probe, and then it'll just kind of wait at the top for a little while. I also noticed this behavior on their slices. So it would probe, home, and then it would sit there at the top and wait. And I'm like, is it done? 5, 10 seconds sometimes, and then it would probe the second time and then be done the sequence. I didn't experience that though in any of my slices. So, the pre-G code is doing the G28 and G29 if you want to do a probe map, M420S1 if you want to load the map. But when it did the probe, the home, G28, it would probe the first and probe the second right away with no delay like you would expect. So that's kind of inconsistent behavior, if anything else, or if nothing else, rather. So I mentioned that I welded to this, and I started, that's the first print I did. It was a little bunny, and I didn't want to damage this too much, so I put this aside, and I don't know why this isn't standard issue and why they come with the build tack material, but Creality offer the same spring steel with PI. So this is a non-textured PI sticker, bonded to the spring steel. It came pre-bonded, I want to say. I can't remember, about this a while ago for one of the Yenders I was testing. And when it's cool, PLA just pops right off, but when it's hot, it's stuck like glue, unless you're touching it with your fingers like I am here. So wipe it down with isopropyl, and this worked like a charm. It's also obviously the perfect size. It slaps right down like that. And I had no issue getting prints to stick, getting prints off, and I never damaged the print surface like I did here. The other thing is now that I've got material kind of stuck into the build surface, if I'm printing like a box or something where that's the surface that's going to be visible, you can end up having some of this purple PLA transfer onto the top of the box, and that's less than desirable. It is nice if you want that kind of sandblasted texture. You could get a textured PEI version of these, like a powder-coated PEI, and that would be kind of the best of both worlds. So that's my spiel about the build surface. The next thing I wanted to mention is the spool holder. So we've seen this kind of snap-on spool holder setup on a few other printers. One thing that I noticed with this one was that no matter what, it's kind of loose and it's angled. And I don't know if you can see that, but it's kind of, the spool would always slide to the edge here and be dragging against the edge, and there's actually like plastic residue everywhere there. I just wish that I could like screw it in like the old Ender style one so that it was actually level, but there's really nothing you can do about that. You're kind of at the mercy of the tolerances there. And you know, while it stops us from wearing a groove in the filament runout sensor like we've seen on the Ender 3s, they've got a, I don't know if I can show you here, there. They've got a brass insert in here. It looks like brass anyway, metal insert. So the filament is not going to wear, whoops, let's get that there. There we go. The filament is not going to wear a groove in the plastic. It's also properly aligned with the plastic, unlike coming down here, so that's going to be less of an issue anyway. But there was shreds of filament appearing all around this hole. So the edges of that are not really chamfered that much. I mean, they are chamfered, but they still left a sharp edge. And so the filament is kind of shredding there. So that causes, well, potentially 2 or 3 things. Number one, it's shredding the filament, so the dimensional accuracy of the filament is kind of thrown out of whack to some degree. Number 2, you've got shreds of powdered filament ending up in here. Over time, could cause a problem. Or you've got shreds of filament that are being carried by the filament down into your extruder here. We don't have that shredding issue at the extruder inlet. There's also a brass insert there, but it's properly chamfered and smooth, and there was never any kind of those symptoms down at the bottom here. The last thing that I noticed was when you home the x-axis here, this upright puts pressure, and you can actually see the way that the cable is turned. It would have been like this at some point. It puts pressure on the edge of the cable here. Over time, those stresses could cause problems, but it's all not bad news. So those are the negatives that I noticed, or potential negatives that I noticed, let's put it that way. Positives, the machine's quiet, it printed flawlessly, and it's a more refined version of the Creality printers that we've seen in the distant past. I am a big fan of direct drive. I think that, and I know that many of our customers are putting direct drives on all of their Ender series printers all the way back. It's nice that it comes with it out of the gate. I'm not the biggest fan of ribbon cables, but if done properly and if properly spec'd for the amperage you're pulling, then it shouldn't be an issue. I think this is a neat little package to be able to just snap on real quick with a couple screws and pop the whole thing off for maintenance. It makes maintenance really easy. I also found that even after hours of printing, I forgot that's on, even after hours of printing, I was a little skeptical at how well the cold side of this hot end assembly would work to draw that heat away from the cold side of the heat break and make sure that we didn't end up with jams or filament softening where it's not supposed to. It worked fantastically well. I can actually, right beside the hot end, I can put my finger here, and even after hours of printing, I could barely even tell that it's warm. Not that it wasn't uncomfortable, I couldn't tell that it was warm, right? So it's doing a very, very effective job at exhausting that heat away. It is a bit of a noisier fan on the side here that's doing that job. It's noisy because it's moving a lot of air. So I was a little bit skeptical at how well such a compact cold side would do. And it is exhausting the air right out the side here, so it's not blowing any of that air onto the prints. So if we are printing in some materials that you didn't want, to be cooled, that wouldn't be an issue either. It's properly channeled out the side. So that was very nice to see. And the cooling fan here, for the part cooling fan, actually moves a lot of air as well for a 48010, right? Again, you hear it because it's a high RPM fan, but some of them don't move a lot of air at all, and that was not the case with this. So let's take a look at some of the prints. So our prints, I've got a collection of things here. Some of these items were from the SD card as test prints. Some I sliced, like this one, but not actually this one, this rainbow one here. So this is a random rainbow filament I've had for a long time. It's PLA. I printed it at 205 degrees. Any hotter than that, and I got stringing. Any lower, and I wasn't getting great layer adhesion. So it's a very finicky filament, this particular one. But it's a slow color changing rainbow PLA. Since this was a small-ish print with not a ton of infill, we didn't get a lot of that rainbow effect, but it's kind of cool how it turns out. It is a silk PLA, so it's got that extra sheen. I definitely could have done a better job with the start and stop points. They're random here, they're not aligned, and we have little zits. That's completely on me. I'm not faulting the printer for that. This thing turned out pretty good. Any of the flaws in it are related to something else. I 3D scanned this. So this is a clay model, 3D scanned and printed on this printer here. We're gonna talk about that in a little more depth in another video. This was one of the SD card pre-sliced files, little cat. It turned out great. It's hollow on the inside, so there's almost like no infill. There is, some infill in between the walls here. It was printed rather slow. It took probably an hour and a half or 2 hours or so for that to print. It does have some thickness to it, so there's a lot of walls there. Turned out good. We don't have any kind of gaps or blemishes in the layers per se. We can see the start and stop endpoints minimally, like very, very little. One thing that I did notice is that in some of these prints, you can see like on his backside here, it's gonna be almost impossible to pick up on camera, but you can see almost that moire effect. It's not salmon skin like we've seen on old drivers, but it's just an interesting artifact that appeared on a lot of rounded objects. I also printed small ducks, small bunnies. That's what you saw kind of burned into the original build surface there. I did lose the bunnies because my kid kept stealing them from me. But they had the same effect on their rounded bodies as well. Other than that though, it worked out great. There were a little bit of supports right here on this paw because that's a steep overhang. Other than that, I don't think there was any supports on this side. Nothing much else to say about that. Again, this is another rainbow filament, but it's like a steampunk kind of rainbow, old random filament I had laying around. I printed one of these cubes. It goes this way. There we go. Turned out good. So what I like about this cube in particular is it tests bridging ability. So no supports, of course, on here. The X turned out good. One thing that I found is, again, this is something that I sliced, is that we have some bulging at the edges. Any sharp corner edges, there's a bit of a bulge. So as you get to those corners, we've used in the past, we've used linear advance to tune out any oozing that happens as the nozzle slows at that corner point. And we're seeing a little bit of that effect here. Now, because we're using a custom firmware and a custom screen here, they haven't exposed any options for linear advance on the screen. They did expose the jerk setting, I believe it's the jerk setting, in a kind of roundabout way. So on the screen under control, under motion, they have something called max corner. So they have max acceleration, max speed, and then max corner. And then steps per millimeter, of course. So max corner is set at 5. So that would be kind of a standard jerk value, between 5 and 10 would be on the aggressive side maybe. We've seen printers with much higher. But more than jerk, I'd need to tune linear advance for sure. It would likely be a very low K factor around 0.06 if I had to guess as a starting point, somewhere around there. That's what I would use on any of my Titan Arrows. On my Hemera, I was around 0.05 or so, even less. Basically, you tend to be lower in the K factor the shorter the path between the drive gear and the nozzle itself, right? And this is a very compact form factor, so somewhere in the 0.05, 0.06. I would print a test print to tune the value. But that would likely completely get rid of this kind of bulging effect at the corners. It's not offensive, but I know that it's there and it doesn't need to be. From a bridging perspective, that entire roof under there is all bridged, aside from the helix in the middle. And you can see the strings of filament. If you scrape them with your nail, a couple of them might be loose, but there's no drooping, there's no sagging at all. The cooling was very, very good. Minor amount of sag across these larger ones here. The X, even more so. So this is what I found interesting. That bridge on the Y, we had no sagging at all. And if you picture the nozzle going around, it goes around this direction typically. If you picture the nozzle going around, as it's moving this way, as the filament leaves the nozzle tip, it's being cooled immediately by the cooling fan, like direct line of sight. As it moves this way though, the cooling is blowing this way as opposed to opposite the direction of travel. And in this section here, we ended up with those ribbon kind of bands. Instead of doing full lines, it was doing infill there, and the infill drooped. It didn't attach to the two border lines. So there's a few things that I can do in slicing there, is I can ensure that there are solid lines on that bridge layer so that the infill is going across those. But the drooping may also have to do with the cooling effect. That's why I like having cooling fans on like either side. You kind of get more full coverage rather than all the air blowing from one direction. But again, I sliced this. I can do some things to compensate for that. It did a good job of bridging. It's dimensionally accurate. The layer bonding and everything's good. There's nothing really to complain about. It's user error, if you will. And this was printed on the PEI here. Popped right off, nice shiny bottom. And the BL Touch did a fantastic job of accounting for any abnormalities in the flatness of the surface, once I set that Z offset, of course. So that's my slice. Another test file was this guy. This is printed in our house brand silk purple, an old spool I had kicking around at home as well. And this turned out pretty good. It was printed like this. And so this raised portion where the screw holes are there had some supports underneath it. Now, they could have used a denser top support layer to end up with a nicer finish on those two raised sections. I did have to kind of scrape and pry that away. And because of the lack of density of that layer, you end up with a bit of a rough texture here, or rougher than it needed to be. So, having a dense top layer on your supports ends up with obviously more bonding to the actual print, but it also ends up with, if you can get it to cool quickly so that bonding is minimized, it ends up with the smoothest layer that you would have on the top, where that interface was. Other than that though, this turned out fine. The actual slice had the bottom layer here, so this is the bottom layer. We'd normally expect that nice smooth surface here, and it is smooth, but you can see that there's a bit of a texture there. And so it's like every second pass of the nozzle was a gap line. So it did a pass, and then a gap, and then a pass, and then a gap, and a pass. And then the second layer was a solid layer. So you end up with this smushed but texturized kind of look to it. I don't know if that's intentional. Again, it's there pre-slice, but it's just kind of like an interesting effect. I did have a little bit of stringing with this material. Again, it's probably sliced for that little package of pre-canned filament they gave us. I doubt that that would have been enough to print all of these items, for sure. So I'm not gonna fault them for that. Beautiful top layer there. It's buttery smooth. And now we have a carrying handle. So this is similar to the handles we would have seen on some of the old Enders. You can't use it here because we've got this guy, but nonetheless, here it is. This one is interesting. The print was printed this way, which makes sense. You would print it this way for the strongest strength in this direction, right? So we're not pulling against the layer lines. But on the bottom here, there's infill, or not infill, there's support material in part of the E, but not in the rest. And it wasn't needed for sure. That's very, very little bridging to happen there. So this material here, I can just break it away like that. There we go. So there was no support in the rest of it, but just in that one. I'm not sure why. And then, of course, in the two areas here where we'd have the bolt to bolt into the hammer nut there, we've got some support material. And I wanted to leave this on camera to show, you know, how difficult or easy it is to pull out. So there's that. We do end up having a bunch of the interface left. And in this particular case, we had poor layer bonding, probably because I printed it or it was printing too cool. So this was printing at 200, and this material wants 205, like I mentioned earlier, to have, well, 205 is the minimum to have good layer bonding. 210 is better, but then you contend with stringing. Like the support popped out well. We ended up with a nice, relatively smooth interface there, and that's where the bolt is going to go, of course. So that worked out well. So final thoughts. If you've watched any of my videos, you know that I'm not a huge fan of custom screen interfaces that aren't open, you know, easy to customize, or at least that don't expose all of the options. So, you know, the TFT35, the Big Tree Touch one, it was nice. It gave you options for everything. You could even access the terminal. I think they called it terminal, the command prompt, basically. This one is a little more confined or controlled and doesn't expose things like the K factor for linear advance. I also don't even know if this firmware has linear advance enabled, to be completely honest. I didn't hook it up through USB to my computer, so I didn't test any of those functions. As I said, I just used a pre-canned profile from Super Slicer. There's profiles available for the Ender 3 V2 for almost all of the slicers now. This one wasn't in Super Slicer. I believe it is in Prusa Slicer. You can port that across. They're forks of the same slicer, essentially. Pretty standard kit. You can basically use a profile for any of the Enders as far as I'm concerned and just adjust the retraction amount as a reasonable starting point anyway. Another thing that I think is interesting is this kind of gradual, maybe, change to these custom extrusions. So while on the Y and stuff, it's really nice because you don't end up with little bits of filament stuff stuck in those channels or buying those little strips to fill those channels or printing strips. It's nice from that perspective, but I know a lot of people have like camera mounts and stuff that they've used hammer nuts and T-nuts to mount to their printers. You can't do that anymore. You can use this kind of, you know, you can print something that has this kind of a clip that goes into these grooves here and clamp it down like that, but you got to figure something else out. So it would kind of be nice to still have those grooves, at least on like maybe the side rails. The uprights, less so because, well, this is moving up and down. You're not going to attach anything here, so I'm totally cool with that. And also on here, you probably would never want to attach much here. This is just a 2020, so you could replace it with anything you wanted. So I'm less concerned about that. But these ones here would have been nice to still have. Likewise, up here, why not just use regular 2020 to give you the flexibility of bolting something there, but at least you can bolt something onto here. On the back, so this rail is interesting because on the bottom, top, and back, they have the standard V slots. They just don't have it on the front. On this rail, it's the same thing. They have it on the top and bottom, but not on the back or the front. Just interesting. So anyway, that's my one personal gripe. I just like having infinite flexibility almost. As I mentioned, I kind of like this package here, especially for like maintenance or, you know, if you're running these in a farm and you want to have the ability to quickly swap out your hot end in the case of any kind of required maintenance or failure or jam or something has gone wrong. You can just couple screws, pop it off, pop the next one on, double check your Z offset, and you're off to the races, right? Then off the machine in due time, you can, you know, do your repair maintenance or what have you. Downtime costs you money if you're running these in a farm, right? So that's it. It's a capable printer. It's full featured. I know that a lot of people are adding direct drive. Now you've got it out of the box. There was very rapid assembly, unlike the original Ender 3. You know, they're kind of moving away from that, it seems anyway. And that's probably for the better because it takes a lot of those assembly variables out of the equation, which makes supporting the printers a lot easier. Hopefully you found all that useful. Remember, like and subscribe and ring that bell to get notified when we upload more videos. Thanks for watching.